Hey, what's going on, everybody? Welcome back. Today's cybersecurity lineup is pretty nasty. We've got malware hiding inside developer extensions, attacking attackers using blockchain wallets as command and control infrastructure, Salesforce data getting pulled through a compromised integration, millions of fake boots, emails hitting inboxes, homebrew shipping a major security focused release, and then we're going to close with two tools that matter. Tenant for AI agent runtime security, and the Warp Gate for Bastion access across SSH, HTTPS, Kubernetes, MySQL, and also uh, PostgreSQL. So the bigger theme today is very simple. The attack surface has moved. It's not just your website anymore. It's your editor, it's your package manager, it's your OAuth integrations, it's your CRM, it's your AI agents, it's your internal access layer. And if you're building software, running an agency, managing clients, or deploying AI systems, this is the kind of stuff you need to understand before it becomes your problem. Let's jump right into it. So, Glass WASM, malware hidden in OpenVSX extensions. Now, this is our first story. This one is very important because it targets developers directly. Glass WASM is a WebAssembly malware payload compiled with tiny Go and hidden inside Trojanized OpenVSX extensions. Now, let me move this over just a bit. Okay, so um, the two reported malicious packages were the xrgd.vs black version 0.01 and the noeli.flint debug version 0.1.1. These were published by an impersonation account called um, Tuna43, and the researchers attributed the activity with medium confidence to the glassworm operator. Now, here's why this matters. A lot of developers think I'm safe because I'm not downloading random exe files. That's wrong. Modern malware does not need to show up as a suspicious download anymore. You can live inside the tooling you trust. Your editor, your plugins, your package manager, your build chain. And this is one of the reasons why, as opposed to downloading tools whenever I have a need for something, I usually say, how viable would it be for me to build this for myself? Like, for example, I built myself a password manager that operates completely in Python that I can run right here on my machine and use that for all of my passwords because I don't trust somebody else's software that they built that I can't see the code for, and I can't audit it. I can't do any of that, especially if it's not open source, and that leaves room for things like malware, right? Things like vulnerabilities to exist because I'm relying on these developers to secure the software that I'm using, and it's putting my passwords at risk. So I'd rather make my own password manager that that is used completely offline by me, and I have all of the code. I know exactly how it works, and I can also update it and make code changes as I need to. Now, getting back to the story, this malware was hidden in extensions for OpenVSX. Now, this matters because editors like VS Codium, Gitpod, Cursor, Windsurf, and other VS Code compatible editors may pull extensions from OpenVSX depending on configuration. So, this is a supply chain problem aimed directly at developer machines. And this payload is slick. It ships with no plain text IOCs. That means you're not just grepping for obvious domains, IPs, or strings. The malware decrypts strings at runtime using an embedded Cha-Cha-20 routine. Then it pulls a Solana wallet for SPL memo drops. That's how it finds its rotating command and control host. Think about that. The attacker is not hard coding the C2 domain in the malware. They are using blockchain memo data as a OOF drop system that makes takedown and static detection much harder. Then, once it resolves the host, it uses nodes child process to run a cross platform download and then execute chain or, or actually a cross platform download and execute chain. Okay. And it runs that through curl or PowerShell. So whether you're on a Mac OS, Linux, or Windows, the payload is going to have a path. Now, the practical takeaway from all of this is going to be this: if your environment installed or activated either of those extensions, don't treat it like, oh, well, maybe nothing happened. Treat the host like an unknown second stage may have executed. That means you want to remove the extensions, rotate your secrets, Check shell history and child process execution. Review network activity. Look for node spawning, curl, PowerShell, or any unusual download behavior, right? And don't rely on only on domain-based blocking because the host rotates, right? Now, the real detection point here is behavior. You want to detect the execution chain. The editor starts extension loads WebAssembly, node spawns the child process reaches out to download a second stage, credentials, SSH keys, cloud tokens, GitHub tokens, NPM tokens, wallet keys, and environment files become high value targets. My opinion is this is where dev security is going to eventually go. The editor is becoming part of the attack surface. So if your company is serious about security, extension governance needs to be treated like a dependency governance. You will not let random production dependency slide into your backend without review. So why are developers allowed to install random editor extensions that can execute code on the same machine that has GitHub access, SSH keys, AWS credentials, and client code? That needs to change. Now, moving on, let me go ahead and close this. So our next segment talks about Salesforce data theft through a compromised Clue integration. Now, attackers reportedly used a compromised Clue integration account to mint OAuth tokens, query Salesforce REST APIs, right? They use those OAuth tokens to do that, and also pull CRM data for roughly 24 hours. So if you guys don't know, when an attacker pretty much is able to compromise an account, via something like OAuth tokens or whatever the case may be, because there's more than one way. I mean, there's cookies, there's lots of ways for an attacker to compromise your account. They don't just have to have your password. Now, if I'm able to query, because the thing with APIs is that a lot of people think that there are people who don't have the know-how to go out and find how to get access to these APIs, right? Like the Salesforce REST API, they were able to query it because they were able to get that OAuth token, right, which gave them access. And from there, they can essentially pull CRM data roughly for 24 hours. That's them essentially pretty much leaking database information or pulling database information, right, from the CRM, whether that be customer information, whether it be any kind of data. Now, some bursts reportedly hit nearly 1,000 queries in 15 minutes. So this isn't that lets you know it's not casual browsing. It's being automated, right? It's automated extraction. They have a script running and they're trying to get as much data as they can before they get kicked out. So the data involved reportedly included contacts, quotes, and messaging. This is the kind of attack that should scare every business, because Salesforce is not just a CRM anymore. For a lot of companies, Salesforce is the business memory. It has customers, deals, quotes, internal notes, partnership conversations, support context, sometimes even secrets that should never have been stored there. And the attack path here is the part that matters: OAuth and integrations. The attacker does not necessarily need to hack Salesforce directly. They can compromise an integration, mint tokens, as I just mentioned, and then use the official API like they belong there. That is why third-party SaaS integrations are becoming one of the biggest weak points in enterprise security. Everyone wants automation. Everybody wants CRM sync. Everybody wants AI assistants connected to every tool. Everybody wants one-click integrations, but every integration is also a trust relationship. And if that integration has broad permissions, old credentials, no IP restriction, and weak monitoring, it becomes a side door into your company. The reports connect this to a long unused Clue credential and the Icarus extortion group using a session ID and hijack Australian mail domain. So what should teams do? First, revoke all Clue-related secrets and tokens if you are potentially affected. Second, review Salesforce API query patterns. Look for unusual volume, weird timing, strange user agents, and bulk access to objects. Third, enforce a IP allow list for integration accounts. Fourth, stop treating service accounts as invisible plumbing. They need owners, rotation schedules, scoped permissions, and alerts. Fifth, audit stale integrations. If nobody knows why an app is still connected to your Salesforce, kill it. My take: CRM data theft is going to get worse because SaaS tools are turning into soft targets. Companies have 50, 100, sometimes 300 apps connected to their core systems. Nobody knows what half of them do. That is a gold mine for attackers. And now add AI agents into that environment. An AI agent with access to Salesforce, Gmail, Slack, Notion, GitHub, and the payment tool is powerful. But if that agent gets hijacked or manipulated, it becomes an automated insider. That brings us perfectly into Tenet later in the show. Now, moving on, we have fake boots emails. So, nearly 8.9 million users were reportedly targeted with emails pretending to come from Boots, the UK health and beauty retailer. Now, the lure was simple: a free beauty sample pack. That is classic phishing psychology. If you don't know what phishing is, get on Google and look it up. But you get a free product, you have a familiar brand, you have a low friction survey, you have a small payment or checkout step, you harvest the user's personal and financial data. The emails send people into a fraudulent checkout flow and customer survey designed to collect their information. The attackers reportedly hosted the phishing page on a compromised Bolivian government webpage and used a compromised UK business terminal server to run a bulk mailing service. This matters because attackers are not always sending phishing from brand new shady domains anymore. They are abusing legitimate infrastructure. A government website has a reputation. A real business server may pass some filters. A familiar retailer brand lowers suspicion. This is why phishing is not just about bad spelling anymore. A lot of people are still looking for 2010 style scam clues. The modern version is cleaner, faster, and better disguised. Now, what should regular users do? First off, don't click promotional email links directly. Go to the retailer's website manually. Check the sender's domain carefully. Be suspicious of free gift checkout flows that ask for payment details. Use virtual cards where possible. And never assume a page is safe just because the domain looks legitimate. Legitimate sites get compromised. What should businesses learn? Now, your compromised server might not be used to ransomware you per se. It might be used as infrastructure to attack someone else. That creates reputational, legal, and operational risk. If your terminal server gets popped and used to send millions of phishing emails, you are part of the incident, even if your own files were not encrypted. This is why endpoint monitoring, credential hygiene, and outbound mail monitoring matter. Give me 1 second. I have returned. Okay, so now moving on to segment number 4. This one is actually not a part of our live stream today. So we're moving on to Homebrew 6.0. Now, this is one of those updates that might sound boring at first, but it is actually a big deal for developer security. Homebrew 6.0 adds tap trust, which means that Homebrew now requires explicit user agreement before third-party taps install or execute code. Now, this matters because taps can run arbitrary Ruby. A lot of people treat Homebrew like it's magic. Brew install this, brew tap that, brew upgrade everything, but package managers are trust engines. When you install something, you're not just getting software, you're giving code a chance to execute on your machine. Now, Homebrew 6.0 adds bubble wrap based build sandboxing on Linux, enabled by default. That brings Linux closer to sandboxing or to the sandboxing model macOS users already had. There is also a new brew bones command that checks installed packages against the OSV vulnerability database. And Homebrew now has an ask mode confirmation prompt for brew install and brew upgrade. The broader point, Homebrew is moving toward more intentional trust, which is good because developer workstation is the new battlefield. You have an extension risk, you have package manager risk, you have build script risk, you have CI/CD risk, you have dependency confusion risk, binary replacement risk, credential theft risk. Homebrew's maintainers are basically saying we need more friction in the right places, not annoying friction, smart friction. A prompt before trusting a third-party tap is not bad UX, it is a seat belt. Another interesting part, Homebrew's release lean heavily on AI-assisted coding, but under a disclosure and human review policy. That is the future. AI should accelerate maintainers, but not replace review, especially not in infrastructure software that millions of developers depend on. Also, Homebrew is getting more aggressive about Intel Mac OS deprecation. No new Intel bottles after September 2026 and full removal by September 2027. So if you are still on an Intel Mac and Homebrew is central to your workflow, you'll want to start planning. My opinion, Homebrew is not just a package manager update, it is the signal. The ecosystem is waking up to the fact that developer tooling has become critical infrastructure. And I would argue that it always has been. Now, moving on to our next segment, we have Tenant, which is a runtime security for AI agents. So we're switching over into product launches now and moving a little bit away from security. So even though this is a security platform, so it's like I said, it's focused on runtime security for AI agents. The category is going to absolutely explode, right? And why that is because AI agents are not just chatbots. A chatbot answers questions, right? An AI agent does things. So it can read files, it can call APIs, it can write code, it can send messages, it can query databases, it can open tickets, it can modify cloud resources, trigger workflows. That means the security problem changes. You can't only ask, did the model say something bad? You have to ask, what did the agent actually do? What files did it touch? What API calls did it make? What network traffic did it initiate? What commands did it run? What reasoning led to the action? Was the agent manipulated? Was the tool call expected? Was the behavior consistent with the policy? Now, Tenet's approach uses a lightweight runtime sensor to watch operating system activity, network traffic, API calls, and model reasoning so risky or hijacked agents can be stopped before they execute harmful actions. Now, that is the right decision or the right direction because prompt filtering alone is not just enough. You can filter out the input, you can filter out the output, you can write system prompts, you can add policy reminders, but once an agent can take action, you need runtime control. Think about an AI coding agent. If it reads your repo, that's normal. If it edits a file, that's normal too. Now, if it runs tests, it's also normal. But if it suddenly tries to curl a random domain and pipe the result into bash, that is not normal. So think about a sales agent now. If it reads Salesforce leads, that might be normal. If it exports the entire CRM at 2 a.m. and posts it to an external endpoint, that is not normal. Think about a finance agent. If it generates a report, fine. If it initiates payments after being manipulated by an email, that is catastrophic. So this is why AI agent runtime security is not optional for serious companies. My strong take is any company deploying AI agents with real tool access needs 3 layers. Layer 1, identity and permissions. What can this agent access? Layer 2, runtime monitoring. What is this agent doing right now? Layer 3, action control. Can we block, pause, review, or roll back risky actions? Tenet is playing in that runtime layer, and that layer is going to become one of the most important parts of enterprise AI security. For builders, this is also a market signal. If you're building AI apps, don't just build cool automations. Build trust, logos or logs, permissions, approvals, and runtime controls from day one. That is how you sell to serious companies. All right. Make sure you guys go and check out Tenet if you haven't already. Now, for our last segment, we're going to talk about Warpgate. All right. Now, this is an open source Bastion tool and privileged access management tool for SSH, HTTPS, Kubernetes, MySQL, and also PostgreSQL. So the cool part is it does not require a special client or SSH wrapper. This matters because a lot of access tools create friction. Developers hate friction. I know I do. Now, ops teams hate weird wrappers. Security teams hate unmanaged access. Now, Warpgate tries to sit in the middle as a transparent access layer. You can use it for secure access to internal servers and services with SSO and RBAC. Instead of everyone connecting directly to production systems, you route access through a controlled Bastion layer. Now, that gives you a better shot at centralized access control, session visibility, audit trails, role-based permissions, cleaner onboarding and offboarding, a single choke point instead of scattered credentials. Now, this is important for small teams too. A lot of startups and agencies are sloppy with infrastructure access. SSH keys everywhere, shared database passwords, contractors with old access, no real audit logs, production databases exposed too broadly, no consistent offboarding process. Now that works until it doesn't. If you manage client infrastructure, you need a grown-up access story. Warpgate is interesting because it gives smaller teams a path toward that without forcing everyone into a heavy enterprise platform immediately. And tying this back into the rest of today's lineup, Glass WASM shows the developer workstation is exposed. Clue, Salesforce shows integrations are exposed. Boots, phishing shows humans and infrastructure are exposed. Homebrew 6.0 shows package managers are adding trust controls. Tenet shows AI agents need runtime controls. Warpgate shows infrastructure access needs a controlled gateway. The pattern is obvious. Security is shifting from protect the perimeter to control every execution point. The editor is an execution point. The package manager, an execution point. The OAuth integration, an execution point. The AI agent is an execution point. The Bastion host is an execution point. The browser session is an execution point. The terminal is an execution point, and that is the modern security model. Now, I want to say in closing, I want to wrap this up by giving you guys a few big takeaways. So, number one, developer tooling is now a major attack surface. So, if you run a team, you need extension policies, package manager policies, and workstation telemetry. Number two, SaaS integrations are not harmless. OAuth tokens can become the keys to your CRM, your support system, your email, your docs, and your customer data. Number three, phishing is still effective because attackers use real infrastructure and familiar brands. Don't judge safety by looks, judge by behavior and verification. Number four, package managers are adding trust prompts because trust can't be invisible anymore. Homebrew 6.0 is a good example of security friction done the right way. Number five, AI agents need runtime security, not just prompts, not just policies. Actual monitoring and control over what the agent does. Number six, access needs to be centralized. Tools like Warpgate matter because direct, unmanaged access to infrastructure does not scale safely. My final thought is this: the companies that win the next era of software are going to be the ones that move fast without being reckless. AI is making teams faster, agents are making workflows faster, automation is making businesses faster, but attackers move fast too. So the answer is not to stop building, the answer is to build with controls, visibility, permissions, runtime monitoring, audit trails, human review. That's where it matters. And the ability to shut down risky execution before damage happens, that's the show for today. Or that's the show for today. If you're watching live, drop your thoughts in the chat. Which story worries you more? Malware and developer extensions, Salesforce OAuth abuse, or AI agents getting hijacked? And if you're catching the replay, comment with the security tool or topic you want me to break down next. Like, subscribe, and I'll see you guys in the next live stream. We have these every single day at around the same time. I want to say 10:30 EST time. So make sure you guys tune in, and I'll see you guys in the next video. And have a great day. I'll always keep coding.